welcome back to my channel. Today we're going to be looking at the topic of systematic organic chemistry. To help you with this overview video, go to the website below where you can download a worksheet which will go along with the video. Let's start with some basic organic chemistry. You're expected to know the prefixes for up to 8 carbons. For 1 carbon, the prefix is meth. For 2, it is eth. For 3, it is prop. For 4, it is bute. 5 is pent. 6 is hex, 7 is hept, and 8 is oct. You could be asked to name anything with up to 8 carbons in the longest chain. There are a number of different families of organic compounds that you're expected to know. The first is the alcohols with the suffix OL for the name. The functional group is called the hydroxyl and has the formula OH. Carboxylic acids always end in oic acid. The functional group is called the carboxyl group and has the functional group formula C double bond O OH. Because of this, it's always found on carbon 1. Esters are a family of compounds made by reacting alcohols and carboxylic acids. They have the suffix -il for the part from the alcohol and -oate for the part from the carboxylic acid. The functional group is called the carboxylate or ester link. The functional group formula is the ester link formula, showing the O joined to a C double bond O. Aldehydes have the suffix -al for the end of their name. The functional group is the carbonyl. This is always found on carbon number 1, so has a functional group formula of C double bond O H. Ketones are also carbonyls. Their suffix is -one. However, these are found within the chain of the carbons. So we have C double bond O attached to 2 carbon chains, given the letters R and R dashed here. Let's look at basic naming rules. The first step is to identify and name the longest chain of carbons which contains the functional group. Once you have done this, you need to number the longest chain from the end closest to the functional group, being aware that this may be from the right-hand side. Where you have alcohols and ketones, you will insert the number of the carbon for which the functional group is joined to into the name between the prefix and the suffix. You need to identify and name the branches alphabetically, using die and try where you have multiples of the same branch. Let's look at some examples. In this first example, the longest chain contains 3 carbons. We can number from either end. Here we have 1, 2, 3. The functional group hydroxyl is on the 2nd carbon. This gives us the name propan 2-ol, where the 2 tells us where the hydroxyl group is situated. In this second example, we have a longest chain of 5 carbons. We have the functional group, the carboxyl group, on carbon number 1. On carbon number 2, we also have a methyl group. When naming this, we put the methyl group first with the number where it is located. So we have 2-methyl pentan oic acid. In this next example, we have a longest chain of 4 carbons. The carbonyl functional group is on number 1, making this an aldehyde. On carbon number 3, we also have a methyl group. This means that the name will be 3-methyl butanol. No number is required for an aldehyde, as the ending -al indicates that the carbonyl group is on carbon number 1. In this final example, we have a carbon chain of 4. On carbon number 2, we have a carbonyl group. This means that we have a ketone. In naming this, we indicate where the carbonyl group is located by putting the number between the prefix for the number of carbons and the suffix for the functional group, giving us butan 2-one. When naming esters, the name indicates which part of the molecule originated from the alcohol and which part originated from the carboxylic acid. The first half of the name comes from the alcohol, which can be found from the structure with the part which has the single O. The part from the carboxylic acid has the C double bond O attached. In this case, we have 2 carbons attached to the oxygen and 4 carbons with the C double bond O, giving us ethyl butanoate. Pause the video now and try to name these molecules. drawing molecules, first find the longest chain of carbons. Draw this chain out and number the chain. For carboxylic acids and aldehydes, the functional group gets placed on carbon number 1. For ketones and alcohols, you place the functional group on the number indicated in the name. You can add on the branches to the appropriate carbons, and then at the end go round and fill in all carbons so that they have 4 bonds, by adding in the necessary number of hydrogens to each carbon atom. In this first example, we have propane, which are 3 carbons. On carbon 2, we have both the functional group hydroxyl and a methyl branch. In this second example, we have butanoic acid, which has 4 carbons. The carboxyl functional group will be on carbon number 1, and on carbon number 3 there is a methyl group. In this third example, we have pentane, which is 5 carbons, and the ending Al, which means that on carbon number 1 we have a carbonyl group. In this final example, we have hexane, which is 6 carbons. On number 2 we have a carbonyl group, indicated by the suffix -one. On number 4 we have a methyl group. When drawing esters, the name indicates which part came from the alcohol and which part came from the carboxylic acid. The first part of the name shows the part which came from the alcohol. Draw out the number of carbons followed by an oxygen. For the part which came from the carboxylic acid, this will then join on to the oxygen with a C double bond O, this being the first carbon in the chain for the carboxylic acid. Here we have hexyl butanoate. Hexyl has 6 carbons, followed by the oxygen from the alcohol. Butanoate has 4 carbons in total, the first being the C double bond O. Pause the video now and draw these molecules. Esters are made in a condensation reaction between alcohols and carboxylic acids. This reaction is slow, so requires heating in a water bath, as the reactants and products are flammable. It also requires concentrated sulfuric acid as a catalyst, and a condenser to stop gases from escaping throughout the reaction. The synthesis of an ester is a reversible reaction. The ester can be hydrolyzed back into alcohol and carboxylic acid. This can be seen by the reversible arrow given in the equation for synthesizing an ester or hydrolyzing an ester. Pause the video now and try these examples. three different types of alcohol. Each of these reacts differently in oxidation reactions. The first is a primary alcohol. This is where the OH group is found on the end carbon, carbon number 1. This carbon contains 2 hydrogen atoms. Secondary alcohols have the hydroxyl group somewhere along the chain. This is joined to a carbon which has 1 hydrogen atom. Tertiary alcohols have a hydroxyl group attached at a branch point along the chain. This means that the carbon that the hydroxyl group is attached to has no hydrogen atoms. The oxidation products of alcohols depends on the type of alcohol which is used. Primary alcohols have 2 hydrogen atoms attached to the carbon where the hydroxyl group is attached. This means it can go through a 2-step process of oxidation, first to produce an aldehyde and then to produce carboxylic acids. Secondary alcohols have a hydroxyl group attached to a carbon which only has 1 hydrogen atom. This means it can only go through a 1-step oxidation process to produce a ketone. Tertiary alcohols have their hydroxyl group attached to a carbon with no hydrogen atoms. This means that tertiary alcohols do not undergo oxidation reactions. There are 4 different mild oxidizing agents that you should be familiar with. The first is copper 2 oxide. The colour change seen when copper 2 oxide reacts is black to brown. The reduction that is taking place is copper 2 plus ions gaining 2 electrons to form copper metal. Acidified potassium dichromate is orange, and when it reacts it will change to be green. The reduction reaction which is taking place is for the dichromate ions Cr2O7 2- plus 14 hydrogen ions plus 6 electrons to give 2 Cr3 plus ions and 7 water molecules. Failing solution is also known as Benedict's and is blue. When it reacts, it will form a red-orange precipitate. The reduction equation is copper 2 plus ions plus 1 electron to give copper 1 plus ions. Tollens reagent is colourless. When it reacts, it will form a silver mirror. The reduction equation is Ag plus ions plus an electron to give silver metal. Pause the video now and try these examples. Reduction is the opposite of oxidation. During the reduction process, there is no middle step for going backwards. If you have a carboxylic acid, it will be reduced back to a primary alcohol, as can be seen here with ethanoic acid. This will be reduced back to ethanol. Take care when drawing the reduction steps that you put back in the hydrogens which were initially removed. Make sure all carbons have 4 bonds. In this second example, we can see a ketone being reduced back to a secondary alcohol. Pause the video now and try these examples. Thank you for watching my video. I hope that you found it helpful. Please remember to subscribe and ring the bell to be notified of new videos. You can also follow me on Twitter at MissAdamsChem and Instagram MissAdamsChemistry for updates on new videos and flashcards throughout the year. Bye for now!